Okay, Assalamualaikum and good afternoon to all my students, MEC281. So we have learned about, in our previous class, we have learned about the electron configurations, how to write the electron configuration and so on, the subshell and shells. Okay, so for this week, for this class especially, we are going to learn about the interatomic bonding. So this subchapter is quite familiar. It also has been learned in the SPM level, maybe during your Form 4 or Form 5, if I'm not mistaken. I thought Form 4. Okay, so you should have the basic, or maybe you have already known about the interatomic bonding. Okay, so let's get started. Interatomic bonding can be divided into two categories. One is the primary and the other one is the secondary. So for the primary, we have three types, which is covered in our subject. There are metallic, ionic, and covalent bonding. So for the secondary atomic bonding, we have van der Waals. Okay, so we are going to learn about the metallic, ionic, and covalent. That's it for the primary, and van der Waals for the secondary. Okay, so let's look at on the ionic bonding. Okay, how is ionic bonding formed? Okay, often found in compound composed of electropositive elements. Electropositive elements means that there are tendency to give or to release their electrons, so they are positive. When you give the electrons, you are positive. You are giving something, giving the electrons, so it is electropositive. And between the electropositive elements, okay, commonly metals, and electronegative elements, okay, mostly non-metals. So electronegative elements are the elements that are accept or receive the electrons from the electropositive. So when you give something, there must be someone who receive your giving. Okay, so giver we call the electropositive. Okay, receiver we call the electronegative elements. Okay, electrons are transferred to form a bond. Okay, large difference in electronegativity required. Means that the large difference in electronegativity required, it means that if the electropositive has one electron in their outer shell, or we call in the valence shell, so the electronegative elements has almost full the electrons valence. So let's say we have sodium. Okay, let's see next slide. Okay, sodium. In bahasa Melayu we call natrium. Actually, the scientific term, other than in English, we call it natrium. But since we are learning in English, symbol Na we call it sodium. Okay, but in German there is also called it natrium. Okay, never mind. This is the sodium in English. Okay, so the sodium, how many electrons sodium has? Okay, if you do not remember, just refer to the periodic table. Okay, so there is 11 electrons. So we have 11. Okay, you can count it by your own self. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1 at the electron valence, or the most outer shell. So when we total up, we get 11 electrons. So there is only one at the outer shell, so it has the positive electropositive electropositivity to release this or to remove this electron to other elements so that sodium will get stable. Okay, so that's why it will donate or release or give to the electronegativity elements such as chloride here, chlorine. So chlorine here. How many electrons in chlorine? Okay, you can also check in the periodic table. If you do not remember, 17. So there are 70 electrons in chlorine. Okay. The first shell here, we have only 2 electrons. The maximum of the first shell is 2 electrons. This is what I covered in our previous video. Okay, so 2, 4, 6, 8, 10, 12, 14, 16, and 17. So there is one missing here. So if the chlorine have one more, so it is very stable because it fulfill all the quota in the outer shell. Okay, so every shell has only maximum of 8. Okay, and if we want have more shells, so there is maybe it has maximum of 10, 16. Okay, that's what you have learned in here, right? Still remember that in the previous class? Yes. Okay, we have until 14. Okay, here partial 32. Okay, but here so many more lah. Okay, let's go back to the ionic bonding. Okay, so chloride on need one, sodium have to release one or remove one, so it will donate, it will give. Okay, one electron is completely transferred. Okay, the electrostatic attraction is what hold the ions together. This is what we call the ionic bonding. So the sodium now becomes the positive ion, cation, and the chlorine itself becomes the anion. Okay, negative ions here because it receives sodium, it is giving the electron, so it becomes the positive ion. Okay, so ionic bonding, the properties of this bonding, there are solid at room temperature. Okay, these are the properties of the ionic bonding. Some of these you have to remember because the properties of ionic bonding give you a brief how to determine certain properties of the materials out there. Okay, it also has high melting and boiling points, hard and brittle, poor conductors of electricity in solid state, good conductor in solution or when molten. So it will conduct electricity when it is on the solution or when molten, but it cannot conduct electricity in the solid state. Okay, why? Okay, if you want to know why, you have to go deeper, try to learn by your own self, and maybe you can explain to me later. Okay, so the bonding of the common ionic bondings are found between the first and 2 elements, between the 7 and the 6. Okay, sometimes there are periodic here, intertable here elements that can also found in the ionic bondings, but it must have 1 or group 2 as one of the elements. Okay, so here I have the tendency to give up electrons, and around here is the elements who required or will acquire electrons. So the combination of between group 1 and group 2 and group 6 and 7, you will have ionic bonding. Okay, so this is just a group exercise. You can complete this exercise, but this is not compulsory. I will just want you to wait. Okay, do the tutorial 2 later, and the deadline for the tutorial 2 is next class, which is next Friday. Okay. Okay, so let's continue with our lecture. Okay, draw the following ionic bonding. Okay, let's see if I can show to you. Okay, group 1 and group 7 non-metal. Yes, we already know about the sodium chloride. How about the magnesium and fluoride? Okay, so magnesium, how many magnesium? Okay, if you just want to do it quick, just know what is the group of magnesium. I know it has 2 group 2, so it has 2 covalent electrons here. The 2 electrons in the valence shell here, the most outer shell. So it will have to give up their last electrons in the most outer shell. So there will be 2, 1 and 2. 2, so 2 electrons that should be released or removed or donated to the other elements. And for the fluoride, we know it is group 17, so it has 7. Okay, I use the other color. Okay, it has 7 electrons in the most outer shell. Okay, so 1 here, 1 electron for the magnesium, okay, can be donated to 1 magnesium, fluorine. Okay, so now it is complete for the most outer shell. But how about the other one? So the other one also you have to give, sorry, okay, okay, so also you have to wait a second. Okay, so now 1 magnesium have to release 2 electrons. So 1 electrons must be received or acquired by 1 atom of fluorine. Okay, so the other one also have to be accepted by 1 atom of fluorine. Okay, so now we have 2 atoms of fluorines that are receiving 2 electrons from 1 atom of magnesium. So now if you receive or you donate the electrons, you are no more an atom. You now becomes ion. So what is the difference between the magnesium and fluorine here? So magnesium become magnesium ions, so it will have the two positive cation, right? Sorry. Okay. So fluorine here will become the fluoride negative because it receives 1 electron, and here also will become the fluorine negative 1. Okay, so now to get an ionic bonding, a complete or stable ionic bonding between magnesium and fluorine, so you have to 1 magnesium and 2 fluorine. So that's how you write. Oh, sorry. I didn't realize my symbol is wrong. Okay. Sorry again. So 1 magnesium have to be paired with 2 fluoride. Okay, so that's why we have the symbol of magnesium fluoride. And you can try with the other elements. Okay, so this is another examples. One more examples. Okay, I have shown you already about the sodium chloride. So this is just another example for the magnesium chloride. Okay, so you can try by your own. If you have a problem, let me know. Let's discuss in our WhatsApp group, or you can ask your questions or problem in our Google Classroom. Okay, let's get a rest for 5 minutes before we continue to the covalent bonding. Okay, I pause here for 5 minutes.